Welcome to a lesson with Dr. Powell. Let's look at the setup for how we might find the volume of a region that's been rotated. And we're going to do this in the same way as we do with cross sections, but we're just going to look, the cross sections might just be a little circular. So as we do this, we take a region here. Here's a little depiction, take a region, and we're going to be rotating it around an axis line. Our axis line we're going to take as y equals -1. So when we rotate it around, it's going to trace out in space, kind of like a wheel type thing, flat on the edge here, but kind of rounded, rounded going this way. Now, when we do that, we're going to think of volume growth in the same direction as the axis, so this way. So imagine taking cross cuts like this. So like, cross cut here, looks like that, another one. So we're taking cross cuts going this way, perpendicular to our axis. So doing that process, we're going to get washer shapes, like a flat washer, like you'd use with bolts or something like that. Or you can think of it as circle and a smaller circle, but you've taken out the smaller circle. So it's just kind of this part right here. So we want to be able to figure out what the area of this is, because the area of that cross section is going to be the derivative of volume growth as we move along this way. So we can take a look at that. If we take a look at a flat washer like this at an arbitrary position X. So at position X, let's see what the cross section looks like. Well, at X, let's kind of label some things. The center of the washer happens at y equals -1. Now, notice y is going to be changing at this X value. So it's nice in this picture to notate different y values, because but X is held constant. So X is held constant, but right here, the axis is at y equals -1. So that's kind of like the center of of what's going on. Now, this inner line right here happens right here when y is 2. And then the outer line right here happens when y is way up here at 4 minus x squared, because this is the equation of the curve here. And so if we want to find the larger radius, we simply take the difference of y values. This y value minus that one. And if we do that, we end up getting 5 minus x squared. Now, if we want to find the inner radius, we simply take y equals 2 minus y equals -1 to get 3. Now, notice what this is here. This is the area of the larger circle here at this particular position X, because it's involving the larger radius. And we square it. And this is the smaller radius, and we square it. So this would be the area of the smaller circle that we've omitted or taken out. And notice the integration bounds it from 0 to √2. That's because we need to determine that this is actually √2 here. And then we can check. If you plug in √2, you get 4 minus 2, which is 2 for the y value. So if you were to compute this particular integral, definite integral, you would get the volume of such a rotated solid. Thanks for watching.